Hi, everyone. I'm Julia from Krannich Solar. Thanks for joining our webinar today with K2 and Fronius. Before we get started, I will be giving a quick presentation about Krannich. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 23 different countries with the capability to ship to over 100 countries. Krannich has been a strong partner to PV installers since 1995 and offers everything that is required to begin and finish your solar installation. Our international purchasing power helped us build strong relationships with your favorite manufacturers, such as K2 and Fronius, to secure the best pricing and availability. With a growing market share, Krannich Solar is a privately owned and self-financed company that ranks among the leading solar wholesalers worldwide. Our experience in delivering solar products worldwide for the last 26 years has made us experts in our field. In 2005, Krannich expanded into the US. With our headquarters in New Jersey, we also have another main branch in California with additional warehouses across the nation, including our warehouses in the Midwest and Northern California. We recently opened a branch in Florida and are expanding into Texas. We are growing every day, so keep an eye out for where we might be next. Our US team consists of over 60 employees that service the Americas and strive to offer the best services and options to our partners. Throughout the years, we have grown our product portfolio to provide over 5,000 products. We have partnered with leading manufacturers worldwide to offer the best material for a project of any size, whether it's an off-grid system, 4-paneled shingled roof, or a megawatt flat roof. Working with Krannich means you'll never work alone. With our streamlined ordering process, each customer at Krannich receives a dedicated sales rep to walk them through each step of the ordering process, from product design to on-site delivery. The solar industry is always innovating and changing. At Krannich, we do our best to make sure you know about the latest products and technologies available. We team up with industry leaders and seasoned professionals to train you firsthand on everything you need to know, and it'll always be for free. And this concludes my portion of this webinar. Here is our contact information if you would like to reach out for a quote or if you have any questions regarding the products or services we offer. And also, if you guys have any questions about what we talk about throughout the webinar, please feel free to use the question function on GoToWebinar. And at the end, we will be able to answer any questions that you have. Thank you again for joining us. And now I'm going to be passing this along to Johan from K2.
All right, Johan's having Wi-Fi issues, unfortunately, so I'm going to share the screen for him and he's going to call in on his phone. So just give us 1 second. All right, I think it might be best if we start with Paul and then circle back to K2, if that's okay.
I'm here. Hello, everyone. Let's just see. All right. For some reason, This wasn't happening before, but all right, here we go. Everyone can see me. Looks like, all right. Can everyone see me?
Yeah, you're all good.
And is my screen up? Just making sure here.
Yes, we see you and your PowerPoint.
Okay, awesome. Hello, everyone. My name is Paul Bowie. I am the Northeast Technical Sales Advisor for Fronius USA. And today I'd like to start off by talking a little bit about Fronius USA and how we came to be. Fronius is a company that was started in 1945 by a man named Fronius Gutner. Initially, he started with welding and battery charging systems, and we eventually made our way into solar. And we expanded globally. So now we have a bunch of subsidiaries throughout the US. I work for the US subsidiary, and I'm located out in New Jersey. And before we get into the topic at hand, I'd like to talk about our motto here at Fronius and what we strive for every day. And as we continue to work within the solar market, we strongly believe in a future where we cover our energy needs 100% with renewable energy sources. Really a world with 24 hours of sun. An example of this is our US headquarters in Portage, Indiana actually features a large PV system, as well as a bunch of our satellite offices and our other subsidiaries. They each actually have PV systems on top of their rooftop to help offset the CO2 that we put off when we are manufacturing and creating our products. So we will get right into it. Now, today's topic at hand is safety. So here at Fronius, when we take a look at safety, it is one of the main criteria to really look at when we're designing a PV system. But we kind of take this one step further. We actually break this down into a few sub criteria, if you will. And the three different sub criteria that we're going to go over today is dealing with switching, AFCI, and connection points, and how all of these relate to safety. So with the first criteria, we want to address safe and reliable switching, and the main reason why we want to address this is because NEC 2017 and 2014 had brought rapid shutdown to our systems. And with rapid shutdown, what we need to understand is that there's a lot of switching on and off that's occurring, right? And why do we need to take a look at this? Well, the main reason for rapid shutdown when it was implemented was in case of emergencies, a quick, efficient, and safe way to de-energize a PV rooftop, right? So why are we bringing this up? Switching standards. Here at Fronius, we offer a string inverter, and all of our string inverters come standard with a DC disconnect at the bottom of it. This DC disconnect is also tested to a switching standard, the UL98B. This standard requires us to actually run that DC disconnect switch under hundreds of thousands of iterations to ensure that it functions as it should and never fails. Now, this is on our inverters that do standard DC disconnects. However, when we start taking a look at other options within the solar market, such as module level power electronics, what we're seeing is that they're starting to do the same thing, right? In this case, module level power electronics on a rooftop is acting like a switch. However, when we actually take a look at the device that's starting to act like a switch and starting to act as a rapid shutdown device, these devices have solid state switches installed inside of them in order to do this switching. The problem with that is these switches on the module level power electronics devices are not tested to UL98B. They are not tested to these extreme conditions in which a standard DC disconnect switch would be tested in high temperatures, extreme temperatures. So the biggest concern that we're trying to bring up here is we're starting to see within the solar market an influx of MLPE devices being installed on top of rooftops. However, they are also now being forced to be utilized as a switch for rapid shutdown. However, this rapid shutdown function is not being tested under UL 98B, so it is ultimately a large concern where we have unfair standards being put across multiple products that do similar functions. However, one product is no longer being required to UL 98B. So this is something that we often keep in mind when we're taking a look at switching. A switch that needs to function as is, but isn't being tested to standard switching requirements. It is something that we should be bringing up with our utilities and AHJs. So again, if we can imagine the rooftop, any rooftop, even any rooftop, and the temperatures and the climate that a roof experiences, it can be quite extreme. And when we put these DC disconnects that aren't being tested into, well, when we put these module level power electronics on the roof that aren't being tested to these DC disconnect standards, then what rises is essentially a risk that is pretty much unknown. It's an unknown risk that we're adding onto the rooftop. So again, this is one of the sub criteria that we'd like to take a look at today and talk a little bit about, so that you can bring this out forward and really start discussions on why that is. Why is it that module level power electronics, although they are doing a lot of switching and being located in an extreme area, the rooftop, why are they not being tested to the same standard as other DC disconnects? Now, the second criteria that we want to take a look at and talk about today is accurate arc fault detection. And now I have a graph up in front of us to take a look at, but it can be a slightly confusing graph. So I like to explain this graph with an analogy. Now, the analogy I'm going to make to you is that imagine you are trying to talk to your friend that's at the end of a very long tunnel, right? As you start talking to this friend down this tunnel, when it's a one-on-one conversation, it's quite clear, right? Your voice echoes down the tunnel and the other person can hear it. But what happens when we start adding more people to either ends of this tunnel and they all start having conversations? What we're going to see is a lot of noise. It becomes a lot more difficult to have a conversation with the person you're trying to at the end of the tunnel. And the same thing occurs within our DC lines. Now, when module level power electronics is implemented onto the DC line of any PV system, what we're going to see is a lot of noise that's being introduced onto the DC line. If you take a look at this graph, the blue line that's going across, relatively low compared to the red line, is actually your DC line coming in, minimal noise, and it's quite stable. But once you start introducing module level power electronics or DC to DC converters onto the rooftop, what we're seeing is a large shift in this signature that's coming through. Now, what do we know about arc fault and its detection? Well, arc fault uses a bunch of algorithms and predetermined arc signatures. So if we have a predetermined arc signature and ranges within that, as we start adding module level power electronics, we start pushing this DC signal out of its standard operating ranges. And so what we can experience is, again, nuisance tripping, unreliable detection, and possibly false stay alive signals. And all of these factors add to the risk of safety within a PV system. So whenever we take a look at options out on the market currently, we want to ensure that our AFCI, that the inverter first and foremost has AFCI algorithms, that it's not something that you can turn off, right? And just hide away with, because it's implemented for a reason of safety. And in order to keep it as safe as possible, we need to start thinking about this DC line and the noise that's being introduced, and if this is going to cause a lot of problems down the line of owning a PV system. And now our final criteria that I want to talk about when discussing safety is going to be connection points. Now there was an institute in Germany, Fraunhofer Institute, and another institute in the UK, BRE National Center, that conducted a study. And what they found in this study was that DC connectors were the main cause for serial arcs in a PV system. Now, they found this to be true because one of the biggest problems that later show up on a PV system generally occurs at installation. At installation, it is the most important time to really understand everything that you're installing. You want to ensure that whatever you are installing is correct and that there's no lack of intermate ability, right? So what I've seen out on PV systems and installations is sometimes people trying to stick Amphenol to MC4 connectors, saying that it works. They've done it before. I know Amphenol also released a message stating so, but through this study, they found that it wasn't the case. Sure, you can essentially put these two parts together, but is it the best and safest? They found that every single time anyone was involved in a DC disconnection or a connection point in general, that this was an area for failure. So the biggest concern with the market currently is the injection of module level power electronics and the increase in number of connection points that's associated with the installation of a module level power electronics. This graph here shows that as we install module level power electronics, the number of connections that we introduce to a system changes by nearly a 2 to 3 factor fold. And with that being said, every one of those new introduced connection points are now going to be an area where you have to ensure is installed properly, and again can possibly become an area of risk for arcing. All right, so hopefully the 3 different criteria, I know that they're not generally points of safety that people are concerned with, but here at Fronius, we like to take all points of safety into consideration. And one of the main things about safety that we have under our control is our products, and what can we implement into our products to ensure that our products are as safe as possible. So again, these are a few extra criteria that we wanted to take a look at today and really just let you guys know. Again, switching, safe and reliable switching is a must-have, and we need to start questioning why module level power electronics is not being required to be tested to the same UL standard, right? UL 98B, the switching standard. Why aren't module level power electronics being tested to this? AFCI, we want to make sure that they are accurate and that we don't implement any devices that cause possible problems to this. And finally, number of connection points. What we learned today was if we can reduce the number of connection points in any PV system, we can improve the longevity and the reliability of any PV system down its lifetime. So finally, our support to you, if any of these criterias pique your interest and you want to talk a little bit more about it, you can reach out to me. Again, my name is Paul Bowie. We have our technical sales team, which is me and a few others. We have our string sizing tool, as well as I offer a bunch of design trainings, as well as additional e-trainings and webinars if that's something you're interested in. So feel free to reach out. And again, here's my information. Again, Paul Bowie, Northeast Technical Sales Advisor with Fronius USA. And I want to thank you all for joining in on my my presentation today about safety. At this point, I'd like to ask, Johan, are you ready?
Yeah, yep, I'm back.
All right, you're all good?
Yep.
I will be sending this your way in just a minute here. And you should have control.
Cool. Thank you guys. Sorry for the confusion there. My internet just went down, so let's share my screen. You gave me access as a presenter? Doesn't show it yet. There.
Yeah. Oh, there was two of you, so it might be the wrong Johan. Let me try the other.
Yeah, I'm on now.
Oh, you're good. Okay.
Yeah. All right. So let me full screen this here. Okay. So again, sorry for the internet drop there. That was perfect timing on my internet provider. But so my name's Johan. I'm the director of training for K2. And we have Drew on as well, who's a part of the training team as well for K2 Systems. We're a racking manufacturer. If you don't know our company already, we work pretty closely with Krannich and in the US as well as Europe, actually. And so we are a racking provider manufacturer based out of California, and we are developing a lot of training for our customers and for installers that are using our products. And it doesn't just go into how to install our racking system, although that's the big focus of our systems or of our training program, but we also are doing a new training program that talks about things like safety and things on how to be efficient on the roof, roofing types and things like that. And I'll talk about that a little bit at the end. So Drew and I both come from a background of installations. I've worked in the industry for about 15 years now, and Drew's been in it for many years as well, working as an installer, and we're now building out a technical training team for K2. So I wanted to go over a couple safety things. We only have a couple minutes each here, and Drew's going to go over our base design tool that actually has a bridge over to the Fronius tool, which is really cool. He's just going to show you quickly how to go through that and what it looks like, just a quick little overview, but you can get more training on that and some of the topics we're talking about right now. So the topics I'm going to cover real quick are just some basic safety things that are really important, and some of it might be obvious, but there's some things I've seen done better than others with crews. As you can imagine, Drew and I are on the roof with many different crews all over the US, and we see all kinds of good practices, bad practices, and we're not teaching like OSHA standards. If you're wanting, fall protection safety courses, you want to take, OSHA 10 and 30 and all those different courses out there to get certified to know everything about fall protection, which we do highly recommend. And we have links on our website for that if that's something you're interested in. So I'm just going to talk about some basic stuff and show you some examples real quick. So crew organization and safety meetings is a big one. Proper construction attire, setting parameters, ladder setup, fall protection use, I would say. And then transferring equipment to the roof, which is a big one that people don't think about. So just to hop right in, this is one of the most important things that I've seen some crews do really well, and some don't even do this at all, and we recommend it quite a bit. So basically talking about having a safety meeting either weekly or monthly where your crews can get together and talk about what are some of the common mistakes we're seeing as far as installation, maybe some problems with equipment, but more importantly, a check-in on safety. Does everybody know what to do standard if something happens? If you see something wrong, call it out, talk to your team. It's kind of a team building time as well to talk to each other and help each other out. So the best install crews and companies definitely have an established safety meeting that goes over requirements, training options, equipment that's being used, inspecting equipment, talking about best practices or problems and solutions, what to look for, supporting each other, and where they can improve and things like that. And obviously a Q&A where people can speak up and say, hey, I noticed this, or I'm having a problem with this. And that goes for safety as well as installation process. So it's really good to have safety meetings and weekly meetings with your crews. Construction attire, obviously this is important. A lot of crews don't do this, some do. Some companies have actual shirts from their company that are high vis, like the neon or orange or red, the safety vest. Sometimes it's required. We work with a lot of companies that are doing big corporate installations for different companies all over the US, and it's required for them to be in hard hats, boots, pants, gloves, eye protection, and the construction vests as well. You can't even step on site sometimes without having this. So, and then you go to residential jobs and you see that some installers are not following any of this stuff. So it's good to have this. There's a good example right there, a crew I was with in Washington where they were on a government project and they had to have all these things. A lot of installers ask about what kind of footwear. Some use skater shoes or Vans, but obviously you want to use boots, but sometimes you want to be more nimble. I found some installers are using these Cougar paws. They're actually pretty interesting products. It's a great boot. It's flexible, it breaks in. Some of them have steel toe if you want that. And then they have this pad on the bottom that you can actually remove and replace. That is kind of like a pad that sticks really well to asphalt shingle and sometimes tile as well. And then if you're on metal roofs, obviously you want to have stickier shoes so you're not sliding around. And if there's any water or snow on the roof, you definitely want to brush that off and let it dry out, because that can just really make a metal roof really slick. Ladder safety, this is a big one. And we're trainers, so we go to all kinds of jobs and sometimes the ladders are already set up. So I always tell our whole training crew, check out the ladder before. If you didn't set it up, definitely inspect it before you step foot or even touch that ladder at all. So you want to make sure that you're standing, see, I don't know if you could see my camera, but if you put your feet at the feet of the ladder, you should be able to stand and hold it there so that that angle is proper. It's not overly bent over, so you're not reaching for it, and it's not super, sloped, hard slope, and it's right close to your chest. You want to have a nice, perfect angle to it. So basically, if you put your feet at the feet of the ladder and reach out, it's there comfortably like a steering wheel, then you're good to go. And then you want 3 points of contact, but a really important thing is having the ladder be secured. A lot of times installers will take a bracket, a C-channel bracket, and a strap and strap it to the underside of the rafter on the bay underneath. You can't see, but a lot of times they do that. Or if you're doing a penetration and you're putting your fall protection, sometimes they'll put fall protection right at the ladder so that you hook in and you go up the ladder and you're safe. And then when you get to the top, you transfer to the next fall protection anchor, which is going to be up at the point of the roof. Sometimes this is required, but also having protection on the gutter and having something secure there. So that middle picture is a great example because you have this little piece of TPO roofing that they just put in the gutter to protect the gutter so it's not scraping it up. They have fall protection tied in, so they have a yo-yo there where they can tie in, and then they have the ladder secured to the roof and it's not sliding around on them. So these are things you want to inspect before you get on the roof. Fall protection in general, I see a lot of bad use of fall protection. So just because you have ropes up there doesn't mean that they're going to be used properly. So the installer on the left picture there in the hard hat, he's actually doing a great job of letting the rope go down the roof, and it's a line, and then he has his moving point bracket that's on the rope, and he moves that based up and down the roof based on where he's working. So he's got it set well. I've seen some installers have way too much slack, so if they were to fall, actually it wouldn't protect them the best. They might even still hit the ground if their rope is too far out. And then the other installer above him without the hard hat there, he has a yo-yo attached to the top. It's just a different style. Instead of a rope, it's a retractable yo-yo. Really good system if you're working on the top side. And then distributing the work, obviously having a rope on one side and another anchor on the other side so you guys can work from different sides. The picture on the right is a job I was on where it was a commercial building. Well, it was a school, and they had actually, when you have fall protection rails already set up at the perimeter of a flat roof or a low slope roof like they do there on the right picture, then you don't always have to be tied in. Just depends on the regulations there, but they're good to go because they have those side rails protected. You can't even get to the edge of the roof. So that's a nice touch for commercial buildings. A lot of government buildings end up doing that. And then I think this is one of the last slides I have here, talking about transferring equipment to the roof. I see this every day, installers taking up some 1, 2, sometimes 3 modules on a shoulder and taking up a ladder, and they're struggling to keep that 3 points of contact on the ladder. And then sometimes you get some really big, ladder extensions and you're going up pretty high. That ladder on the right was very wobbly. They got it done, but I've seen crews use these ladder lifts that are really, really helpful. And it might take some time to set up because you have to have a little mini generator and it powers it up. But once you have that, you can have an installer on the ground prepping modules, setting them up, sending them up, and then the installers on the top can take them, install them. He can bring it back down with the control. He can bring up mounts, tools, everything, so that you don't have things falling off the roof. And going back to this picture real quick on this intro picture, setting a perimeter is really, really important. And a lot of installers laugh at hard hats because sometimes you're on the roof, but when you're on the ground, you should be wearing a hard hat and you should set a perimeter so that homeowners or their kids are not running in that section. That is a construction zone and nobody should be in there, so that things don't fall on them and there could be an issue. So, and that's where they should be wearing hard hats. So the installer below here is loading everything up, has a hard hat on actually. So this is just a brief overview of some safety things that we talk about in our new K2 Pro partnership training program that we have. So if you're interested in more details on this or getting training with K2 on products as well as roofing and mounting and also some basic safety and PV basics, we're doing a whole new program that we've just developed, and we're launching the first modules of training probably at SPI. So if you're interested in this, we're already doing trainings in person with crews that are using our products. So if this is something you're interested, by all means, get in touch with us and we can work out some kind of training program or get you set up to go through the K2 Pro partnership. So that's it. I just wanted to do a quick overview. And again, if you want Drew and I's contact info, we're the technical trainers here. There's our emails and phone numbers. And if you have questions, feel free to type them in. So I'll hand it over to Drew. If you want, feel free to screenshot that there and get in touch with us. And I'll hand it over to Drew so he can talk about the design tool for base. So give me a second here. Okay. So let's see. Sorry, give me a second, Drew. Sorry. Pull it over to you.
Yeah, all good.
All right, make presenter, there you go. All right, you should have controls. It might take a minute there.
Let's see, is that working now?
Yeah, we can see your screen.
All right. Yeah, so I'm Drew, like Johan said in the introduction here. I'm a technical trainer for K2, come from an install background, been leading crews for 8 years before coming to K2. And just wanted to go through our solar design tool, online design tool. So first things first, go to k2systems.com, and to get to this homepage here, it's just k2-systems.com. And then if you look through here to service, you can find our online design tool underneath our Basecamp Education Center there. Click on that, brings you to a web page with some tips, cheat sheets, some information on how to use the tool. If you scroll down, there's also a video of Gal Roeder. He's the K2 base product manager, giving a couple updates and improvements on the system. So if you're at this page, you can start base from this button here. But also, if you look at the header of our website here, there's just a quick link to get to K2 base. All right, so now that I'm here, I'm already signed in automatically. That's me right there. So you're going to want to log in or sign up so that you can save your projects here. And when I start base, it brings me to this dashboard with all my latest projects. Let's see, on the toolbar here, you can start a new project, open a project, and you can see that these options are here as well for opening a project from a file downloaded on your computer, the Docu app, which I don't think is available in the US, but just Europe for right now, K2 Plus. But you can open a project from here, the sidebar as well. Save, we added that you have the option to auto save your project as you're going along, so you don't have to worry about saving. Let's just turn it to auto for now. You can download the project after you're completed here, or at any time really, to your computer. You have an undo, redo button, which is nice if you have to make any mistakes. Some news from K2, YouTube tutorials on how to use the design tool, FAQ and FAQ. And if your question isn't answered in this FAQ, you can go to our chat here, and you can use either the WhatsApp, if you have an iPhone, iMessage, to talk directly to our tech sales department, and they'll get back to you. And yeah, so let's get into it. Let's start a new project. I'm gonna choose something up by me here, up in the Northeast, upstate New York. All right, so there's my house. And let's name this just Taylor, yeah. You can choose a planned date of installation, but that doesn't matter for you to continue on to the other sections. The design method does matter. If your AHJ is using an older design requirements, minimum design loads, you can choose whatever your AHJ is using, 705, 710, or you can use the updated 716. Yeah, let's name this customer as Lawrence, and let's give him contact information, whatever you want to do. You can put a phone number in there. You can also tag this project with different tags, so when you're searching, you can actually pull it up by the tags. Let's say it's a shingle project, hit enter, and that'll add a new tag. And okay, so this is our new project we just added, and now we're going to go through the design requirements here. So if you choose that 716, it can automatically input your snow and wind loads for the region you're working in. Up in the Northeast here, we have 110 mile per hour wind, 40 per hour or 40 PSF snow load, but you could also input that manually if you wanted to. The wind exposure is going to be urban, suburban, and risk category normal. I'm going to go through this pretty quick here, just so we have time for questions at the end, but also just to show you guys how easy this design tool is. So this is a gabled roof, and with that option, you have the option to draw a rectangular array. If it's a hip roof, you have a couple of different options to choose from. This is gable, we'll go rectangular. It's a composite shingle roof covering, and this is important too. What's nice about this is it limits our product selection in the next sections of the design tool, so that you're not having to sift through our entire product list. And we'll just name this roof 1. So then when you click add, you will draw out the roof you want to attach your solar array. So I'm just going to go from the peak here, peak to peak, and create a nice rectangle for our array. Looks like that's pretty close to the bottom of the roof. Okay, and some of this information you'll want to get from a site assessment, but we also have the option to do a street view, and you can kind of see how tall the building is and what the pitch of the roof is. But this, we'll just say it's a 2-story, so it's going to be about 25 feet. Not the biggest pitch, pretty low slope, 20 degree pitch. And we'll choose our, now it's saying the edge distance of our outer rafters has been recalculated depending on these parameters here. And now we'll choose our roof drainage, which is going down the roof south that way. We're using shingles. 24-inch rafter spacing. You can change this, but in this region we'll say typically a 24-inch rafter spacing. And this is also part of what you wanted to do with your site assessment, kind of gauge how far in those first rafters are for your attachment zones. Just generated an automatic response here with 9. We'll just keep that for now. Yep, you can add a topographic factor if it's been approved by your engineer, your permitting engineer, if you have something in mind there, or you can just keep it automatic. This is going to be partially exposed, 26 PSF. If there is any roof obstructions, you can choose line, polygon, rectangular, and add a roof obstruction here, although there isn't any on here, but let's just say there was one down here. And that's how you would draw out your obstruction. You can choose the height and offset of the obstruction as well to kind of give you a gauge on the shading. But let's just undo that. Let's say there is no roof obstruction. Any notes you want to add as well? Okay, so now we're going to choose our modules, and that's going to give us our length and width so that we can figure out how many panels we can put on this roof. You can do it user defined if for some reason we have an exhaustive list of modules, but if for some reason you can't find it on here, you can always input it manually based on the tech sheets of your modules. Like I said, we have a really long list, so if you also want to limit that list to choose from, you can go to the UL 2703, and that'll just give you a list of modules that have been tested to UL 2703 for grounding and bonding. And it gives you the top 3 that you've been using, the last 3 modules you've been looking at, or you can choose from a list. Let's say we'll do Hanwha Q cells, and I don't know, we'll do a, let's just say 350. Now for shingle, you have 2 options here, shared rail or cross rail. We'll just do a normal dual rail, cross rail system. And you can choose to populate the roof with as many panels as possible, or you can draw out the array. Let's just say we're going to do a complete roof here, and let's see what portrait looks like. And add. And there we go. That gives us 18 modules, 9 across here. So you can add in a minimum roof edge distance. So if you had to get 3 feet on 3 sides, maybe, or 4 sides, you could do that. You could also do it manually with this toolbar here. You can edit the module array outline. So let's say I want to have a typical distance here of 18 inches, 1.5 feet from the ridge cap, and then let's do 3 feet on either side here. And you can see those numbers changing down at the bottom or at the top. That's close enough. There we go. This is your distance between modules, accounting for our mid clamps. You could choose to do something in portscape as well. If you had some obstructions, you can do bottom row, top row, and landscape. It gives you a new array. And choose your end clamp. So that'll account for your rail cantilever, your extra rail that you're going to hang outside of the array if you're using our standard end clamp, but let's just use the Yeti hidden end clamp. On this array, since it's so small, we don't need any separation, but this is accounting for your thermal gaps here for expansion and contraction, vertically and horizontally. And there we go, saying everything looks in order, and it actually gives you the rafters, the roof attachments, your rail, everything right here. And this is where we're going to choose the mounts we want to use in the racking system. So let's go with the splice foot. And with that option, you have a deck attached or a rafter attached option. We'll stick with rafter since we're in the Northeast here. And I want to use Crossrail 44X dark. Let's say it's an end phase system here, so we don't want to use any omega clips, any hay clips. We can go straight into our rail channel with the wires and just use the top channel clip. Let's throw some end caps on there, and this will all get populated into your BOM. So it's important to choose your accessories you want. Everything looks good. Continue. Gives you some cantilever tension, length looks okay, it says. Your fastener utilization, and brings us to our summary. So it gives you a bill of materials here, pricing, and then if you had different roofs, you could pick the different roof covering. Over here on the left sidebar, you have some options. You can export to Green Lancer if you have an account with them, and they can give you some rapid permitting, some pricing on some structural engineering, K2 design software. This is that API bridge we were talking about with different companies here. We have Fronius, so you can link to there and get into your string inverter sizing and designing. You could also export to CAD and a DXF, DWG file. And then what we want to do is generate a PDF report. Gives you the project data, bill of materials, all this type of structural analysis. And if we generate that report, it should pop up. We can open this file, and there we go. And this will give you some information on your project, the panels we're using, the job site, some engineering. I don't know if this is too zoomed out for you guys to see. There we go. And then, yep, your roof attachments, rail, and some more engineering. And then at the bottom here, you have your bill of materials. Okay. That was all I really wanted to share. Now, yeah, I'll pass it back over to Krannich here.
Yeah, and Drew, I just wanted to add that this is a good tool if you're trying to design systems for ASCE 716. There's a lot of new requirements, and there's new roof zones and wind speeds now that are very specific to solar, and they've gotten more defined. There used to be only 2 roof zones, and now there's, I believe, 6. And there's interior. What's that?
You can see that in the report here. Yeah.
Yeah.
My screen is still sharing. You have the yellow, red corners. Yeah.
Yeah, exactly. So this is all built in with our engineering. So if you're wondering what's the best mount to install, because we have deck attached mounts, we have rafter attached mounts, and if you want to see the different spans in your areas, you can do that by switching the mounting systems in this tool. And then for distributors, it's really good to know what the installers are designing, what they're using, having a BOM. Then it has all the part numbers and they can go through it. So it's a really helpful tool. And having those bridges between all the inverter manufacturers, as you showed, you can even use the Fronius one there. So it's really handy. So I highly recommend getting up to speed on how that design tool works, especially if you're the one designing your systems and then sharing it with your rep at Krannich and any of the Krannich reps if they want to learn it as well. It's very handy. And then we offer support to double check the BOMs to see that it's done right and if there's anything missing or maybe things to look for. And then obviously you want to throw in some extra materials as well as you would on any project. So just wanted to add that. And then we can, I don't know if we want to do Q&A or however you guys want to do it.
Yeah, if anyone has questions, please feel free to add that in the question function in the chat. So we were asked, does PV system works for Latin America as well?
What was that question again? Say it again.
Does the PV system work for Latin America as well, is what we were asked.
I believe our design tool does, but I know we have an office. If that question's for us, we have an office in Guadalajara and also parts of South America. So we do work with a lot of companies in South America, Latin America, definitely in Mexico. So if that's something you're interested in, we can put you in touch. I think that was Juan. If you have questions, Juan, you can get in touch with us and we can put you in touch with the right people in that country or that you're specifically asking for. Our Guadalajara office is very good at connecting. If it's not in Mexico and it's in South America, we can connect you with the right K2 reps there. So the answer is yes for the most part. This design tool is more for, I think, US, but they have their own version and ways of doing designs and they can walk you through that.
Great, thank you. We also got Fernando saying hi to Johan and Drew. So
yeah, we have a lot of good customer base all over Latin America. I think he's in Mexico, maybe. Yeah, Fernando, we have you probably already know our office in Guadalajara, so appreciate the support. And then I did see some fun comments. Someone said that one guy had a hard hat and one didn't. On the roof, you don't really need to wear the hard hat. Some guys choose to take it off. I was on that job. He took it off because it was starting to rain and he just was getting wet and he wanted to cool off and the rain stops. But on the roof, it's not a requirement. And that was just a residential job. Most residential installers don't even wear a lot of that safety stuff, sadly, but they were doing it right. And you know, they just took it off for the roof work. But the hard hat's most important when you're down below.
Yeah, to add to that, they do become very useful when you're working underground mounts, a lot of sharp metal edges.
Definitely. All right, I think I'm looking at the questions now. I think that's most of them besides comments.
yeah, if nobody has any more questions, we can wrap up today's webinar. Thank you so much for everyone who came out. I hope you guys all learned some good information.
Thanks for having us.
Yep, thank you.
Have a great day, everyone.
All right, thanks everybody.
Bye.
All right, bye-bye.